Welcome everyone. In this video I'm going to show you how to control your stepper motor by using an Arduino and a TB6600 control circuit and the AccelStepper library. So this library is very good because it's very powerful and it's very flexible. So you can control your stepper motor in many ways, and it's a very good library to control your stepper, and you don't really need to struggle with a lot of things. So I will go through my code and I will explain most of my code, but it will be uploaded to Pastebin as usual, so you can get the code straight and try to modify it for your own taste. So if you can see that I just include this AccelStepper library. You can get this from the library manager, so it's easy to get it. And then I will use three variables which are connected to the stepper motor. So I will have here it's received distance, but this is basically the number of steps, and then this will be the speed, and then this will be the acceleration. And then I will have a command which will contain a character and two numbers. So the command is a character, and I have 5 different commands. So I will use the character S to start the motor, and this will need the speed and the distance, and then O and C is the same, but the difference between them is that the motor will rotate in the other direction as the other code. So O will, let's say, go to clockwise, then the C will go counterclockwise. A does nothing, just updates the value of the acceleration, and N is just stops the motor as soon as possible. And then I have these two Boolean variables, new data and run allowed. New data is basically a Boolean, it's a switch. I use it as a switch to see if there was a new command on the serial port or not. And run allowed is that whether we started or not to move the motor. And then we just basically initialize the motor. So we have the motor number 1. You can have several motors with this library. So this is connected to the Arduino by the pin number 8, which is the step or pulse pin, and pin number 9, which is the direction pin. And then we have our setup. So we basically just set up the basics for the Arduino. So we start the serial port, and then we just print a message to show that the Arduino works and connect it to the serial port. So if you open the console of this software, this development software for the Arduino, then this message will show up in the console. And then we just set up some default values. So this is the maximum speed in steps per second unit, and this is the maximum acceleration in steps per second squared. Regarding the speed, this is like 2000 steps per second. If you have your stepper motor controller set up for, let's say, 400 microsteps, that means that one revolution will take 400 steps for the motor. So if your speed is 2000 steps per second, that will mean, or that means that the stepper motor will do 5 revolutions per second, because that based on the number of steps of the microstepping will result this. So if you give like 4000 here, then it will result in 10 steps per second. And that is like, if you have 10 steps per second, that is 600 revolutions per minute. So it's a quite high number. And then I also disable the outputs, which should mean that there is no current flowing across the coils. I do this because I don't want the stepper motor to get hot. And then in the loop there are basically two functions, and they just go over and over. I will show you the serial because that's more important. So the check serial is basically, it checks the serial port whether there is a command coming or not. And in the loop it comes every time when the loop starts over. So if there is a data here, then we see that the string of the incoming command, or the incoming string, is basically the first character of this is our command, so the S, C, O, A or N or whatever characters. So we put this first character in this variable, and then we also say that new data is true. So then we can go to the following if statements, and here I'm using if instead of using switch case because there are not so many ifs. If there would be like 10 or more, I would use switch case, but in this case I don't really feel like using it because it's not that necessary. So if there was a new data, so we received the command, then we start to pick which command we received. So for example, if we receive the command S, that will mean that we want to move the motor. So we allow the running, and then we read in the following numbers for the number of steps and for the speed, and then we just print them out so we can check if if the Arduino received the numbers, and then there is just a message, and we set the speed and the distance or the number of steps according to the received numbers. Then we can have other characters like O. This does exactly the same as the previous command with the S, so I don't explain it, but you can read the code in the link in the description. And then there is the C. This is tricky because it does the same until a certain part. So we allow the running, we read in the speed, and we read in the distance and the speed or the number of steps. We print them out, and then we start to fill in the variables. Speed is the same, but since we want to move in the other direction, so let's say the positive direction is the clockwise direction, now we want to move with this command in the negative direction, so counterclockwise. And this library works in the following way. So if you want to move in the positive direction, you just give the direction as a positive number. But if you want to move in the negative direction, so let's say counterclockwise, then you give a negative number. So we have our number, of steps, and just we multiply it by -1. So then the code will know that, okay, now we have to move in the other direction. So that's all. It's very, very simple. And then we have the N. This just stops the motor immediately. So we disable the running. We reset the position to 0. I will talk about this thing a bit later. And then we just print that we stopped. So we stop and we disable the outputs. So we make sure that there is no current running through the coils. And then this doesn't do any moving or movement. So this just does the following. We don't want to move the motor, but we want to update the acceleration value. So in principle we just read the number from the serial port, and then we just update it. So the new acceleration value will be stored, and then we just print this X updated. So this means that the value is successfully updated for the to the new number. And then after one of these if statements finished, we step out from this part of the code, and then we set the new data to false, because if it would be true, then the software would stuck in this loop, so it would continuously try to check these kind of variables, whether I sent S or whatever, and then this would result in an infinite loop. So we said that now there are no new data received from the serial, so this is false. So this was basically the check serial method. And now we go to the continuous run. So somehow using these if statements, we enabled the running, so run is allowed. And now we go into this part. So if the absolute value of the current position is smaller than the received number of steps, then we go in. But why do we need the absolute value? So for example, if you give a negative number, that means that, for example, you give negative 2000 and you start from 0. So you step one step minus 1, minus 2, minus 3, and so on. But if you arrive at the final position, which is minus 2000 steps, the number of steps will be still smaller than the received distance, because we send the received distance as a positive number, and then we multiply it by minus 1 in the code. So the software will not know that whether it should compare a negative number with a positive number or the other way around. So I thought that, oh, okay, we just want to use the relative positions anyway, so I just take the absolute value, and from let me show you, from this part of the code, the software or the library will know that it has to move in the other direction. So you see that since we have the multiplication by minus 1 separately, and this number is not negative when we send it as a value, then we need this absolute value here. Because if, yeah, as I said, so if this is fulfilled, like let's say we are at minus 2000, then it will be still smaller without the absolute value than the received number of steps. So it will result in a infinite loop, and we don't want that. So then we turn on the power, let's say, and then we just run. And if we arrived, so if this is basically fulfilled, then we go to the else part. So we disable the running, we disable the power, we print the position, the current position. So if we said that let's move 2000 steps, then this part will be 2000. And then we reset the position to 0, because at this moment I just want to move relative movements and not like absolute movements. So I don't want to do like let's move 6000 steps in the positive direction and from that move back 3000 or whatever. So I just want to move like, okay, let's move in the positive direction something, and then let's continue from there, but let's make that new position to the new 0 position. So that's why I reset. But you don't need to do it if you want to work with like absolute values. So if you have a defined 0 point, then you should avoid this. And then I just print out the position again, just to make sure that the current position is 0 for real. And in the demonstration you will see this actually. And in the else part, so if run is not allowed, we just quit this method. So then what we do is we check the serial. If nothing happens, then we go to the continuous run, but since nothing happened, so for example run is not allowed, then we go back to the check serial, and this goes on and on until something happens. And then we receive a command with the numbers in the check serial. We allow running, so after this is completed we step in the continuous run code, and then we do the movement according to this set of commands. So now I will show you the thing in practice. So I show you how to control the motor using this library, and you will see that you can change the acceleration, you can change the speed, you can change the distance, and it works very nicely. So now let's jump to that part. So as you can see, I started the serial communication, and you can see my circuit here. So I have the stepper motor here. I put the screw just here, so you can see the actual position and the displacement or the rotation. This is the TB6600 control or driver circuit for the stepper motor. So basically, if we start from here, we have two enable pins, we have two direction pins, and we have two pulse pins, and then we have the outputs for the two coils of the stepper motor, and then of course we have the ground connection and we have the power supply connection. So what I do here is I have each negative and each positive pins separated. So what I did here is that the enable minus is just hanging in the air, and then the enable plus, the direction plus, and the pulse plus is connected to the circuit board right here. So if you can see, so this is the enable plus, and then here it comes the direction plus, and then here this is the pulse plus. So these are connected to the 5-volt output of the Arduino, just right here, and then the direction and the pulse are on the corresponding legs, which you can see in the code. So the direction is connected to the 9, and the pulse is connected to the pin number 8, and then the power supply is just this regulated variable power supply, so you can change the output voltage or whatever. And then this circuit has the switches here. So the first 3, if we start from this, you can change the microsteps, and the last 3 is to change the output current. So you can see the table here and here, and by changing the positions of these dip switches, you can have different microsteppings, and so on and so on, and the same for the current. And what I have here is the 400 microstep setup. So this is what it has, and then we have the two coils. They are connected, and basically this is the wall setup. So what I do now is just basically I tell the software to step 2000 steps, and that should be like 5 revolutions. So after 5 circles, the screw should return there, and I will just I will give a very slow speed, or relatively slow speed. So I just type in S and 2000, so the number of steps. I hit the space, and then let's say 1000 steps per second. And I should hold the motor because it does a jump when it starts. So you see, it returned quite quickly, and then you can see on the terminal that the number of steps was 2000, and then we reset the position to 0. So now I know that the O command, the open, does the same, but let's see. So O, 2000 and 1000, so 2000 steps and 1000 steps per second. So it's just, let's start it. 5 rounds or 5 revolutions. So this is it. And if I do the same with C, that's the close command for my code, and that is the other direction. So the same 2000 steps and 1000 steps per second speed. 5, and then it ended up at the same spot but with the other direction. And now I will do a longer run just to show you that I can stop the motor during runs. So like, let's start with S 20,000 and with the same speed. So it runs, and then just it stopped. So I hit N and it stopped. And now I change the acceleration, so A, and let's say 2000. So it's updated now. So what I do now is to check how it looks like. And now I give more steps again, just to see how it accelerates. Let me hold it. So it's the same. So let's change it to 3000. And now again. So you can see that it reaches the speed very quickly. And now let's see with a higher speed. So let's see it with 4000 steps per second. And the acceleration is still the same previous. And you should also see that it is not only accelerating, but it's decelerating as well. So it will not stop all of a sudden, but it will stop slowly. And then let's speed up more, double of this speed. Let me hold it. It's quite cool. And then I increase the acceleration value to 5000. I hope it will work. And then the same command, 20,000 and 8,000 for speed. Yeah, it works. So let's try another speed. $16,000 I'm not sure if it will work. Yeah, it seems like it worked, but I'm not sure if the speed was higher than the previous or not. But let's try a very slow speed then, like 100. And let's just make 2 laps or revolutions. 1, 2. Now I can feel that the motor is quite hot, and this is because when it runs it picks up all the maximum allowed current. So maybe this driver for this small motor is a bit overkill, but it works very nicely. As you can see, if I combine this library with this circuit, then I have very good options to control this stepper motor. So it looks very nice, and I think I will stop here because I showed you most of the basic things, and I will make some more videos to discover more options with this library, because as you can see, it's a very flexible library, and it's a very powerful library, so you can give a lot of different commands to the stepper motor, and then you can control it very nicely. So yeah, I think I showed you what I wanted to show, and in the next video I will try to do some other interesting things with this circuit and with this library. And if you have any questions about the library, or if you want me to show you some specific things with the stepper motor controlling or other things which are related to this topic that I show you right now, then just leave a comment, and I will try to come back as soon as possible and come up with some solution for you. So yeah, this was all, and thank you for watching the video, and see you next time.